let's start with the session. Okay, bubble sort. Right. In today's session, we will right understand how does a bubble sort works and also how to implement bubble sort. Okay. So what is the meaning of bubble? Right. See, bubble means right. You know the water bubbles or soapy bubbles like these. Right, these bubbles, right, whenever these bubbles come in contact with each other, whenever these bubbles come in contact with each other, okay, then they will burst. So what I'm trying to convey here is whenever, right, two bubbles they come in contact with each other, right, they burst. Okay, so the concept here is the bubble sort basically works on adjacent element comparison, right, adjacent element comparison. Okay, you need to compare the adjacent elements. Okay, now what we will do is we will take one array here. Okay, we will take one array here, okay, with few elements inside that. Okay, so 1 2 3 4 and 5. So here, right, here let's fill the array with few elements. For example, 50, 40, 30, 20, 10. Now we are working on sorting this array in ascending order, right, sorting the array in ascending order. Okay, so what exactly we will do here, we will, right, compare the first element with second element. We will compare the first element with second element. So if the first element is bigger than second element, we will swap the two numbers. We will swap the two numbers. So if you swap the two numbers, what will happen here? Now the array becomes, right, now the array becomes here 40, 50, 30, 20 and 10. Now what we have to do, you need to compare the next two elements. Now you need to compare 50 with 30. Now you need to compare 50 with 30. So if the first element is greater than second element, if the first element is greater than second element, then you need to swap the values. You need to swap the values only if the first element is greater than second element. You need to swap the values, right? Now, after swapping, what exactly the values will become? It becomes 40, 30, 50, 20 and 10. So this is the second comparison, after the second comparison. Now in the third comparison, you will compare 50 with 20. So, right, if the first element, while comparing, if the first element is greater than second element, if this condition is a true, then again we will swap the values. So after swapping, what does the values will become? What does the values will become? Right, it becomes 40, 30, 20, 50 and 10. Right, now again you will compare 50 with 10. So if the first element is greater than second element, then we will swap the values. After swapping, what exactly happens here? The array elements will become like these, right? 40, 30, 20, 10 and 50. Now, if you observe carefully here, this one entire task what we have done, this entire thing, we call it as first pass. We call it as first pass. Now, in this first pass, what exactly happened here in the first pass? In the first pass, if you observe, the biggest element, right, is sorted at the end. The biggest element is sorted at the end. Why biggest element is sorted at the end? Because we are doing ascending order. If you are doing descending order, then the smallest value will, right, get sorted in the end, right? So this is called as first pass. This is called as first pass. Now what we will do is we will repeat the entire comparison process, right, for these remaining elements, leaving this 50, because 50 is already sorted. 50 is already sorted. Now we will repeat the entire process for the first four elements. Okay, we will repeat the entire process for the first four elements. So let's take those values: 40, 30, 20, 10, and 50. Okay, so this element is already sorted. This element is already sorted, correct? Now what I will do is, okay, okay, now what we will do is we will, right, start comparing the adjacent elements again from the beginning. Again, in this second pass, this is called as a second pass. Now what we will do is again we will compare the first element with the second element. If the condition is true, first element is bigger than second element, then again we will swap them. Again we will swap them. After swapping, what does the values will become? Values will become 30 and 40. Now this time we will compare 40 with 20. Again, if the first element is greater than second element, then again we need to swap it. Okay, again we need to swap it. So after swapping, what does the values will become? Values will become, okay, 30, 20, 40. Right? Now again we will compare it. Now again we will compare it. Right, now again we will compare the third element with the fourth one, the next adjacent elements. If the first element is greater than second element, you need to swap the values. After swapping, what exactly happens here? This 40, right, will get sorted in the last. Now I can say that two elements are sorted. Now can you see here, these are the sorted elements. And this entire thing what you have done is, it is called as second pass. Are you understanding? Is everybody understanding? Okay, now, right, after in the third pass, all the three elements are, right, sorted at the end. Right, all the three elements are sorted at the end. Now we are going to start with the fourth pass. In the fourth pass, again we will compare the first element with second element. Right, if the first element is greater than second element, then again you need to swap them. Again you need to swap the elements. Okay, you need to swap the elements. So after swapping, if you have a look at here, right, all the elements get sorted. After swapping, you can see that all the elements are sorted. So what all things we need to understand here? Okay, what all things we need to understand here? So this will be our fourth pass. Okay, I'll just zoom out from this. I'll keep it in overall picture, right? So now we'll work on something. So total number of elements. How many elements are there in an array? Total number of elements in an array. See, if you go with the number of elements as five, because the array contains five elements. So if array contains 5 elements, how many number of passes will be present? How many number of passes will be there? N minus 1. So number of passes are n minus 1. Instead of 4, can we say it as n minus 1 number of passes? Correct? N number of passes. Now observe here carefully, right? Observe here carefully. This is the first pass. Okay. In first pass, how many comparisons are occurring? How many comparisons are we doing in the first pass? How many number of comparisons are happening in the first pass? Number of comparison in the first pass. How many comparisons are happening? How many number of comparisons are happening? 4. Correct? Or can we say it as n minus 1 comparison? And in the second pass, how many number of comparisons are happening? N minus 2. Correct? N minus 2. Now in the third pass, n minus 3. And here in the fourth pass, how many number of comparisons? N minus 4. Correct? N minus 4 comparisons. Means only one comparison. So, right, what we can make out from this is first point, bubble. Okay, one second. Okay, bubble sort, bubble sort. Okay, first one is right. We we need to compare. We need to compare adjacent elements. Where adjacent elements. We need to compare adjacent elements. Okay, second one. We need to compare adjacent elements. Next, right, number of passes will be equal to n minus 1. Okay, third one, number of comparison, right, comparison is equal to n minus I minus 1. This I, right, where I is equal to, right, pass number, right. For example, it starts from 0 to n minus 1. 0 to n minus 1. So 0 we will call it as first pass, 1 is equal to second pass, 2 is equal to third pass, and 3 is equal to fourth pass. Now how to build a logic for this one, right? So let's start building a logic. Now always remember, right, we will always pass the first pass, right? Inside first pass we will start comparisons, right? We always start the pass, right? We will start the pass, and inside each pass we will do the certain number of comparisons. So first loop what we need to write is, we need a for loop I is equal to 0, I less than n minus 1, I plus plus. This loop keeps track of, keeps track of, right, this loop keeps track of number of passes. How many passes will be there, that will be counted. If n is equal to 5, right, and I value will be 0, 1, 2, and 3. So how many times the loop will execute? 4 times. The for loop will execute 4 times. So in short, this is taking care of number of passes. How many passes are there? When the first pass starts, means when I is equal to 0, how many times the comparison should execute? So to count the number of comparisons, to count the number of comparisons, right, for j is equal to, for j is equal to 0, j less than n minus I minus 1 and j plus plus. This loop keeps track of number of comparisons in each pass. Okay, j for loop is keeping a track of number of comparisons in each pass. Now inside this loop means j variable is taking care of index of comparisons. J loop is taking care of index of comparisons. Now if I have to write the comparison, if ARR of j is starting from 0, first element, ARR of j is the first element, it needs to be compared with the second element. So what is the second element? ARR of j plus 1. ARR of j is the first element, then ARR of j plus 1 will become second element. So you need to compare these two elements. If the first element is greater than second element, then what we need to do? We need to swap. So temp is equal to ARR of j, okay, ARR of j, then ARR of j is equal to ARR of j plus 1. ARR of j plus 1, then ARR of j plus 1 is equal to temp. So this will swap the two values. Then end of for end of I variable. Right? Have you understood this code? It's quite simple. Right? I hope you enjoyed learning. Let us write a program and understand this. Okay. So let's open a compiler. Now I'm just waiting for it to like load. And by the way, right? Remember how many number of passes will be there in a bubble sort? N minus 1. And how many comparison will be there? N minus I minus 1. And what is the I value? I value is indicated by which pass is going on. Okay, because as pass number increase, if the pass number is increasing, the number of comparison will also reduce. As the pass number is increasing, number of comparison will also reduce. Right? Number of comparison will also reduce. So first step in writing a program is always what? Declaring variables. Okay, declaring variables. Then I need number of elements. I need two variables for loop traversing. Then I need one temporary variable. Okay, after that, reading input. What all input we need to read? Enter size, enter size, and then scanf, and then scanf percentage d double quote comma ampersand n. So once you get the size of the array, the next step is we need to read elements. So enter array elements, enter array elements. For I is equal to 0, I less than n, I plus plus. To read array element, I need to traverse. I need to traverse. So while traversing, I need to read values and store them in an array. So this is how we read array elements. This is how we read array elements. The next step, once we get the array elements, the next job is sorting. Right? Bubble sort. Bubble sort. Okay. Let's start working on bubble sort. So the first step is control how many times how many number of passes should be there. So I is equal to 0, I less than n minus 1, I plus plus. So this will tell number of pass. Okay. Inside each pass, how many number of comparisons we should do, how many elements needs to be compared, right? We need to compare n minus I minus 1 and j plus plus, right? This will tell us number of comparisons, right? Number of comparisons. And in this one, what we have to do, we need to compare. So for comparison, which variable is keeping a track of comparison? Is it I variable or j variable? Which variable is taking care of number of comparisons? Is it j variable or I loop? Very good, j variable. So if I want to compare the adjacent element, don't you think I need to use j index only, right? So arr of j, if arr of j is greater than arr of j plus 1, you need to compare the first and, right, first and second adjacent elements. If it is true, then we need to swap them, arr of j. Then arr of j is equal to arr of j plus 1. Okay. Then arr of j plus 1 is equal to temp. Right. This will help us to sort the array elements. This will help us to sort the elements. Once the sorting is done, let us print the array element after sorting, right? Just to check whether the elements are sorted or not. So to print the array elements, again I need to traverse. Traversing means you need to write a loop. You need to write a loop. So printf percentage d slash t double quote comma arr of, sorry, not j, I. Okay. Now let's execute this code. Give 5 elements, 50, 40, 30, 20, 10. Array is getting sorted now. Array is getting sorted. Array is getting sorted. Okay. Now I'll also give you, right, when to use, right, array, sorry, when to use bubble sort. Chalo, instead of this, I'll keep it in the writing pad only. Okay. Now the question comes is when to use, when to use, right, bubble sort. When to use bubble sort. Okay. It must be used, it must be used, right, when we have, when we have less number of elements, when we have very less number of, right, elements, only in that case we have to use bubble sort, right? Okay. And next point is time complexity. Time complexity of a bubble, how much a time will it take to sort an array? In the worst case, it will be big O of n square, right? It will be big O of n square. See, if you are running one for loop, if you are running one for loop, then it is called as big O of n. Okay. But if you have a loop inside a loop, you have a loop inside a loop, then it becomes O of n square. If you have a loop, inside that you have another for loop, inside that you have another for loop, then this logic will take O of n cube. This logic will take O of n cube time. So like that we find out the time complexity of the programs. So are you guys clear on bubble sort now? I hope you enjoyed understanding the logic. Let us start selection sort, right? Let us start with the selection sort. Oh, sorry. One second. I'll just keep the code here. Okay. Now, let's go ahead with a selection sort. Let's go ahead with a selection sort. Selection sort. So, what is a selection sort? Right? Right? So, in this one, right, we select a right, we select an element, an element from right from unsorted array, unsorted array, unsorted array, and swap it with right, swap it with or put it in, put it in sorted array. So let us understand it in a more broader view. So for that, let us take an array here. Okay. So let us take an array here with some elements 0, 1, 2, 3, 4, and 5. Let's take the elements as 50, 40, 30, 20, 10, and let's say 7. Total 6 elements we have, right? Sorry, it is 5. Now what we will do is we will divide the array into two parts. As I've told you that the array will be divided into two parts, right? Which is called as sorted and this is called as unsorted. Okay. So let's start writing the points here. Procedure, right? Procedure to work on, right? The array is divided into two parts, into two parts. Okay. The first one is sorted, right? Second one is unsorted. Okay. So what exactly we will do in this to sort the array, right? Okay. To sort the array, right? Step 1. Okay. Find smallest element, smallest element in unsorted array, unsorted array. Find the smallest element in right unsorted array. So let us assume minimum, right? Okay. So which is the smallest element in the entire array? It is 7. But instead of taking 7, right, note down the index of 7, right? Instead of taking the smallest element, note down the index of a smallest element. Keep a track of index of smallest element in unsorted array, right? Okay. Once you got that index, step 2, right? Swap it with, swap it with first element of, first element of unsorted array, first element of unsorted array, first element of right unsorted array. So you need to swap it with this and this needs to be swapped, these two needs to be swapped. Okay. So if you swap them, right, what will be the answer? If you swap them, what will be the answer for that? One second. Okay. Okay. So after swapping, this will be, the array will look like this. 7 and 50 will come. Okay. Now after that, there is last one step is remaining, right? That is step 3. After swapping, what we need to do is, right, move the boundary, move the boundary, move the boundary. That means you will move this boundary of sorted and unsorted, right? Have you understood now? Right? Move, you will move the boundary now. Okay, you will move the boundary. Now you will repeat. Step 4 is repeat till n minus 1 element, not n minus 1, n minus 2 element. So till here, right, we should keep on repeating it. So now you find the smallest element. Now the smallest element is 10. What is the index of 10? It is 4. Now you will swap these two, you will swap these two, right? If you swap it, this one becomes 10 and this one becomes 40, correct? Then after that, move the boundary. Now again find the smallest element in this entire array. Find the smallest element in the entire array, right? Which is 20. Note down the index of that, which is 3. Note down the index of that. Okay. So now once you get that smallest element, swap it with the first element of unsorted array, right? You need to swap 20 and 30, right? Once you swap, this 30 and 20 gets, right, exchanged. Now after that you will move a boundary. So you need to keep repeating this process. Now you look at here, what is the smallest element? Smallest element is 30. What is the index of that? Which is 3. You will swap 30 with 30 only, self swapping. Then you will go here, you will move the boundary. Now the smallest element is 40. You will swap 40 with 40. Now after that, then the boundary will move. Once the boundary comes to this position, there is only one element in the array. Now should I have to sort it? Because if there is only one element in the array, that means it is already sorted. That means the array is already sorted. Are you, I hope you are understanding this. Let's go for repetition. Okay, let's go for repetition. Now consider an array with certain number of elements. Okay, I want to, right, sort all the elements in, right, in ascending order. Okay. Okay, so these are the array elements. Now what I need to do here is, what I need to do is, this is my boundary. Initially there are 0 elements in the sorted array. There are 0 elements in the sorted array and every element is present in the unsorted array. This is the assumption we will go ahead with. Now, right, step 1 is what? Find index of, index of smallest element, index of smallest element in unsorted, right, in unsorted array. Okay, so, right, you take one variable called as minimum index. So start from here and try to find out which is the smallest element in the entire unsorted array. Okay, start from this point, find the smallest element in the entire array, and the smallest element in the entire array is 3. This is the smallest element. Now instead of storing 3, store the index of 3. so that we can swap the exact memory, right? Now, once you get that, the second step is swap it with swap it with first element of first element of unsorted, sorry, huh, first element of unsorted. So this is what the swapping will happen here, right? So swap these two. So after swapping, what happens, right? After swapping, what happens here? 3 will come here and 7 will come here. Okay. Once this job is done, after the swapping is done, the next step is, right, move the boundary of move the boundary of unsorted or sorted. Now this will become a boundary. So after the first step, one element is sorted in the beginning. The selected element, particular element is selected and it is sorted. Particular element is selected and it is sorted. Right? Now keep repeating it till all the elements are sorted. So now start from here, traverse the entire unsorted array, find the smallest element index. Now what is the smallest element index? It is 2. Now you swap this with first element of unsorted array. Okay, swap it. If you swap, this will become 6 and this becomes 15. Okay, then after that move the boundary. After that move the boundary. Then keep repeating the step. Traverse the entire unsorted array, find the index of smallest element, then swap it with a first element. Swap it with a first element of unsorted array. If you swap, this becomes 7, this one becomes 15. Now, after that, move the boundary, right? Then find the index of smallest element, which is 4, right? Swap it with the first element of unsorted array, right? Then after swapping, right, move the boundary. Now, how many elements are left? Only one element is there. Is it required to repeat the entire step? Is it required to repeat the entire step? No, not required. So, right, if n elements are there, then, right, boundary will move till n minus 1. If you start from here, the boundary, it will move only till here, till n minus 1, right? So this is what, right, I have explained here. Okay. Now, finding the smallest element in the array, we have discussed it, right? Finding the smallest element in the array, we have discussed. Let's start writing a code for this. Okay. Now, I already have written declaration of arrays, right? We have written declaration of arrays. We have written a reading size of the array. We have written reading array elements. Now, instead of bubble sort, what we have to write? Let's remove this bubble sort. Now, we need to write selection sort. Okay. Now, to do this selection sort, we need something called as minimum index. So this is used for keeping a track of smallest element index. So, right, now the boundary should move from where to where? Boundary should go from till 0 to n minus 1. 0 till n minus 1. So I is equal to 0, I less than n minus 1, I plus plus. Right? To move boundary from 0 to n minus 1, right? Or to move the boundary 0 n minus 1 times. You need to move the boundary, right, n minus 1 times. When you start with the first unsorted array, so first element assume first element ARR of I. Okay. Okay. ARR of I. This is assume first element of unsorted array as assume first element index as, right, as minimum index, right. Let us assume first element, sorry, first element index as a smallest element index. I will assume the first element is the smallest element in the beginning, right. Now I will traverse the entire remaining array. See, if I assume, right, if I assume minimum index, okay, now if I assume minimum index as 0, okay, this is boundary, this is the first element, okay, I variable is, right, right, I have assumed the first element index as the smallest element index. Now this 3, I have assumed 3 as a smallest element. Now this 3 needs to be compared with the remaining elements, correct. 3 will needs to be compared with remaining elements. If the index of first element 0 is assumed as minimum index, then the remaining index will start from where, right. If I is assumed as the starting index, this value needs to be compared with the remaining elements. Remaining element index will start from where? It starts from I plus 1. I plus 1. So j will start from I plus 1 till the last element you have to search. So see, search or traverse remaining unsorted array, right. Remaining starts from where? Starts from I plus 1. If I is the starting point of, if I is the starting part of unsorted array, I will assume that as a already assume smallest. Then I have to compare that assumed with the remaining. ಯಾವುದೇ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದ್ರೆ you have to compare it with the remaining. Now if ARR of j, sorry, if ARR of I, not I, minimum index assumed is minimum index, if this minimum index is greater than ARR of j, see, this is a assumed smallest element, and ARR of j gives you remaining elements of unsorted array. It gives you remaining elements of unsorted array. So when you compare them, if the condition is true, then minimum index is equal to j. If condition is true, if this condition is true, if assumed value is bigger than the remaining element, then which one is smaller here, right? This will be the smaller if the condition is true. Then j will be the index of minimum, right. Like this you keep on doing it for the entire array, keep on doing it for the entire array. Once you come out of the right, finding the smallest element, then write the steps. Temp is equal to ARR of minimum index, swap the smallest element with first element of, right, with the first element of unsorted array. So ARR of I is the first element index. ARR of I is equal to temp. So selection sort is finished. This will keep repeating till the last element. I hope you guys have understood this. Enjoy learning.